All right, hello and welcome. This is going to be our arc length and sector area homework help video. Problems 1 and 2 ask us to find the measure of each angle. How I want to do this is I want to trace this spiral and I want to count my angles, but you got to pay attention to the unit that your reference angle is given in. In this first one, we know it's radians because it's not degrees. It doesn't have the degree symbol. And the other giveaway is this pi on top. Radians almost always have a pi somewhere in their answer. So as I count my angle out, I'm going to count in radians. And one thing that I should remember is that each half turn is pi radians. So a full turn is 2 pi. So I'll just write that up here. 1 turn equals 2 pi. So let me start tracing my spiral. That's pi, 2 pi, 3 pi up to here. Let's keep going. 4 pi gets me to there. And then I can either add the extra little piece here or overshoot and subtract. I'm just going to add in this extra piece. I got to know what this is. So real quick, I'm going to convert back to degrees because I think we understand that a little bit better. Pi over 3, that's 60 degrees. So this here must be 30 degrees to add up to the 90, which is equal to pi over 6. So I've rotated 4 pi times plus pi over 6. Let me write that out as just a little expression. 4 pi plus pi over 6. Take this first one, multiply it by 6 over 6 to get 24 pi over 6 plus pi over 6 equals 25 pi over 6. Double check that can't be simplified, and then also double check that you got the direction of the rotation correct. If we go counterclockwise, that's going to be positive rotation. If we go clockwise, that's negative rotation. This was counterclockwise, so it's positive rotation. 25 pi over 6 is the correct angle measure. Actually, we can double check that. Oh, didn't put the answer key in here. I think that's right. All right. Find the length of each arc. For this, we need a really simple formula. It's just S equals R theta. But the trick about this is that theta must be in radians. And this is the radius here. So radius, radius, and radians. So maybe I can help you remember it. Radius, radians. So for this first one, 240 degrees is not in radians, so I got to convert it real quick. Now, if I'm converting degrees to radians, I got to multiply by a form of 1. And one thing I know is that pi radians is equal to 180 degrees. I set it up like this so that the degrees will cancel out. Divide the top and the bottom here by 60. And I get 4 pi over 3. All right, so that's our radian measure. I can now multiply, well, essentially plug that in for radians. Radius is going to be 7, giving us, let me just get a little space over here. S equals 7 times 4 pi over 3, which equals 28 pi over 3. That can't be simplified, so that is just our length, but then let's look back. It's a length, so we got to go figure out the correct units. It's meters, so meters for number 3 there. All right, and then these ones are actually easier because the degree measure is given in radians, so you don't have to do the conversion at the beginning. Just go ahead and multiply them. This one here, 10 pi over 4, or 5 pi over 2 miles. And yeah, it doesn't say, round it to the, or give a decimal approximation. So I won't, just leave pi in your answer there. All right, the area of each sector. So the trick to finding the area of a sector is find the area of the whole circle and then multiply by the percentage that's shaded in. You can do radians or degrees for this. You don't have to convert it at the beginning. So what is the whole area of this here? The whole area of this circle is pi r squared. Pi r squared, but I'm going to plug in a 12 for radius. This is going to give me an area equal to 144 pi miles squared. Now, what percent of that circle is filled in? Well, it's 225 out of 360. So I'm going to multiply this number up here by 225 over 360 times 144 pi miles squared. I'm going to put that 144 up top. I'm going to do this in my calculator. So let me get out my calculator. 144 times 225 equals 32,400. Divide that by 360. You know, here's the trick to it just turned, okay. I thought we were gonna have to convert it to be fractions, but it's just 90, which actually looking back, I guess that makes sense. So it's 90 pi miles squared. So 90 pi miles squared, or square miles, is our final answer. Let me try to pick one that's going to have us actually have to convert a fraction. We'll do number 10. So first, find the area of the whole circle. So area equals pi times 19 squared. 19 squared. Let me use my calculator on that real quick. 361. So the area equals 361 pi square miles. What fraction of this circle is shaded in? Well, a whole revolution would be 2 pi. So the fraction that is shaded in is 4 pi over 3 all over 2 pi. Let's make that a 2 pi over 1 so we can copy dot flop it and get 4 pi times 1 over 3 times 2 pi gives me 6 pi. This here simplifies to be just 2/3. So 2/3 of this circle is shaded in. I'm going to multiply that 2/3 times 361. So 2 divided by 3 times 361 equals this. Okay, we did get a decimal, so I'm going to hit math, enter, enter to turn it back into a fraction. 722 pi over 3 square miles. 722 pi over 3 square miles. And that is for number 10 there. All right, state if the given angles are coterminal. If they're coterminal, then I could start with the smaller one and get to the bigger one by just adding multiples of 360 degrees. So let's just see. So 230 plus 360, that equals 590, which is this number here. So yes, these are coterminal. Let's try this one over here. 295 plus 360. 5, carry the 1, 655. Yes, these ones are coterminal as well. All right, so that'll do that for this video here. Hope you have a great rest of your day.